All right, my last video got cut off just a little bit. So the just to recap where I left off, if we redefine the sine and the cosine here with its true definition, we're looking at the unit circle. If we have an angle in standard position here and draw a radius with that theta, that angle in standard position, the point where that radius would hit the unit circle is going to have x and y coordinates that are the where the cosine and the sine get their definition. So the cosine is defined as the x coordinate of the point on the unit circle with that corresponds with that angle in standard position. And the sine, the y coordinate, the sine gets its definition from that y coordinate for that same theta. So whatever that point happens to be, if you just make that angle, there's a point on the unit circle that radius would land on. That's what the cosine and the sine are defined as being. So it really is just as simple as that. The cosine is just that distance, that horizontal distance right there. The sine is that vertical distance right there. So now, with that definition, we can start to make sense about why some of these angles have the same values, why some of these sines and cosines have the same value. Because look, if we just go horizontally across here, we can see there's another point over here that has the same y coordinate. So it's going to be a different angle. If I were to put a radius over here on this side, that's going to have a different angle. But the sine, the y coordinate is going to be the same. And since that's how the sine is defined, it's going to have the same value. So we can see that looking down here at some specific example values. So for the sine, suppose we have this angle 60 degrees. The sine would just be the y coordinate there, which is the square root of 3 over 2. And so if you just look horizontally straight across, and we can draw this line over. Let me do that. Just draw that line right over. We can see that point right there is um, going to have the same y coordinate, right? So it has the square root of 3 over 2 as the y coordinate. So the sine of 60 degrees and the sine of 120 degrees are both going to be the same because they have the same y coordinate. And we could even extend that idea, right? So if we went 360 degrees around and then another 60 degrees, so 420 degrees, that would also have the same sign, right? Because it's going to be landing on the same point on the as the 60 degrees here. So there's going to be lots of values. You can keep going around that circle as many times as you want. You're going to get the same. If you land on either one of these 2 points, the sine of those angles will all give you the same thing. For the cosine, we can do the same idea here and kind of take a look at this. The cosine is the x coordinate. Well, there's another point on the unit circle, same idea, that has the same x coordinate. If I just go vertically down, right down there, we can see, well, that angle 300 degrees would also land at a point on the unit circle that has the same x coordinate, so the cosine is going to be the same as well. Okay, so that takes care of the sine and the cosine. In the next video, we'll talk a little bit about where the tangent comes from and how we can make sense of its statements from the earlier slide.